Hello, I'm Martin from BoCo, and I'm here to introduce you to Cobo, a contagious disease testing robot. The UK does over 1 million COVID tests a day. They are, and will continue to be, a key weapon in the fight against COVID, especially considering the spread of new variants. On-site rapid testing has also been suggested and implemented as a solution to reopening areas of the economy like air travel and concerts. Only last week, Barcelona hosted a concert attended by over 5,000 people using this kind of testing. But this does come at a cost. Healthcare workers are 11.6 times more likely to contract the virus, so we want to try and further protect healthcare workers when overseeing this type of testing. Here is Cobo. It uses an expanded Turtlebot 3 at its base and is designed from the ground up for contagious disease testing. This system prevents staff needing to interact with the patients. The system also manages the rooms in the testing centre, preventing patients from bumping into each other. The system can run multiple Cobo robots at the same time, with the central controller choreographing their movements. It provides a screen to display a video of the testing process to help the patient carry out the test fully. Patients can interact with Cobo just by speaking to it. They can ask questions, like when will I get my results back, and they can also request the help of staff. This section relies on the Amazon Web Service Lex, which passes the patient's speech. With a reduced need for staff, the system can allow for a higher throughput or longer operating hours with existing staffing. Think of Cobo as the self-serve checkout of disease testing. I will now hand over to Lewis, who will show you how the Cobo system works in a testing centre environment.
Hiya, I'm Lewis, I'm part of Cobo's hardware and presentation teams. Today we're going to see two animated user cases to show how the public interacts with Cobo and how your staff will monitor and control the testing site through Cobo. To begin with, meet Alex. Recently she's been showing some COVID symptoms and has booked herself in for a test. She receives a confirmation email which contains her booking's unique QR code. As a potential vector for infection, Alex wishes to minimise her contact with other people before she can confirm she's not infected. Upon arriving at the test site, instead of being greeted by a potentially vulnerable person, Alex is instead met by Cobo. Let's see how their interaction goes.
Please put on a face mask. Welcome to the testing site. I'm Cobo.
Hello.
Hi, can I see your QR code?
Yes.
Great. Now follow me to the testing booth 4.
Okay.
Cobo is now leading Alex to her assigned testing booth. Cobo has previously mapped this testing centre's layout, and as such uses this map to localise itself and move efficiently throughout the centre. Once arrived at the booth, Cobo supplies Alex with a testing kit. While a used test isn't being stored, Cobo is constantly decontaminating its storage unit through the use of several UV LED lights. Alex has a few questions about the testing procedure, which Cobo is happy to answer.
What do I do with the labels?
Please place one of the serial number labels provided on the vial which you put the swab inside, and one on the plastic biohazard bag.
And when will I get my result back?
Your results will be sent by email and as a text to the mobile number you provided when you registered online. It can take up to 2 days.
Without any further questions and feeling confident in what to do, Alex then proceeds to complete the test. Alex deposits the test within Cobo's storage unit and informs the robot that the test is complete.
I've put the test back in the tray now.
Please follow me to the exit.
Cobo then stores the test securely and leads Alex to the testing site's exit.
Thank you and goodbye.
Alex can go home knowing that she hasn't risked infecting or becoming infected by a staff member at the testing site. And with this, the user case is complete. However, we'll also take a quick look to see how your staff will interact with Cobo. Once set up, each Cobo unit will connect to a local central server, which monitors the current step of the testing procedure, battery life and position. From here, the staff member can send commands to each Cobo unit and monitor their status. Once Alex has left the centre, Cobo returns the test to the staff room. Here, a staff member stores the test securely, gives Cobo a quick disinfect and wipe down, and then sends him back, ready to greet new patients. I hope this look into how the Cobo system works has been insightful. If you wish for a more detailed explanation, you can view an interactive user case on our website. Now I'll pass back over to Martin, who'll cover Cobo's cost and potential expansions for the future.
On the left you can see our calculated actualization budget, the cost to get this project off the ground and produce one system with a single Cobo robot. The approximate unit price of one Cobo robot sits about £1,000, but if you were to enter large-scale production, the unit cost would likely drop. The cost to set up a full system would be £1,000 per Cobo robot, and then the overhead hardware. This is a phone or tablet, a central computer, which could be any desktop, and a Wi-Fi connection in the testing centre. Here you can see Cobo side by side with two of its competitors. These robots are not directly designed for infectious disease testing, but could be easily converted. You can see that Cobo, while not the cheapest, retains the rich feature set required for the task in hand. A few quick notes. Firstly, the touchscreen of Cobo is only being used as a screen. You'll notice also that Cobo has a shorter battery life than the other two. This could be improved by installing a larger battery. There are a number of additional features and research we would like to have done in this project, but haven't been able to. Given extra time, we would interview testing centre staff, pending ethics approval. We would test in a mocked-up testing centre. We would implement multiple language support, add a temperature sensor for gathering additional symptom data, and implement the facial recognition of staff. No doubt a few of you are sitting here thinking, well, that's all well and good, but COVID will be over by the end of summer and we won't have to worry about it. But there is the issue of variants appearing, and the fact that COVID will be staying with us, it seems, but just decreasing in its potency. But even when COVID is, buried and forgotten, Cobo will not be going into the landfill. Cobos could be converted to other types of robots, such as museum guides and reception robots with new software. All the components are standard, and they could be sold or reused in other robots. The components could also be donated to schools to help teach computing and robotics. And the actual plastic shell, which is the only non-standard part, is biodegradable and can be recycled. Cobo, the self-serve checkout of disease testing, allowing for efficient testing centres while protecting frontline staff. Thank you for your time.